All right, now we're getting ready to review our lesson 4. We're going to have 3 different lessons on lesson 4. We're going to have ratios, we're then going to have rates, and then we're going to have unit rates, and then we'll go right into lesson 5. So our lesson 4 ratios should be a pretty easy lesson to remember how to do. It should be a pretty easy A for everyone when it comes to solving for ratios. With ratios, we remember that there are 3 different ways to write a ratio. We're comparing something to something else. So it could be how many boys there are to girls. And the word to tells us that it's in between the 2 things that they're going to be comparing, and the one before the 2 is always first. One after the 2 is always last. It could be comparing a part to a whole, such as how many girls there are to the entire class or how many boys there are to the entire class. When we talk about writing our ratios, then we remember there are 3 different ways. We can use the word to. We could write it as a fraction, and we remember that the top number is always going to be the one that's listed first in the ratio comparison. The bottom number, the denominator, is always listed second. Or we could use the colon, and the colon is just going to separate just like the 2. So we have the first one that they talk about, and then the second one that they talk about. So when we talk about these, then we have some examples and practice problems in our book. Write the ratio of circles to squares. So I have to look and count how many circles there are. Well, there are 5 of them. And what am I comparing it to? What's the second number always going to be? It's how many squares there are. So I have 7 squares. So I'd have to write 5 to 7 when I do it. Or I could write the fraction form 5 to 7. Or I could use the colon 5 to 7. Or we could be doing a shape compared to the whole. So when it talks about this one, it says, well, I'm going to compare squares to shapes in general. So when I look at it, I know I have 7 squares, but when I add the 7 and the 5, I get the 12. So I use the word to for my ratio, or I use the fraction form, and the first one always goes on top, or I use the colon, which also says 2. Each of these say the same thing when I say them verbally, 7 to 12, 7 to 12, or 7 to 12. When I use ratios then inside a box and I know that I have a consistent ratio, then I have to figure out, well, what is my ratio and what if I change one of those numbers? The ratio has to stay the same. So if I'm talking about how many students I have for one table, I have 5 students for every one table, and that's what the information tells me. Well, then what if I have 2 tables? Well, that's when I have to remember that I multiply numerators and denominators of fractions, and that whatever I multiply the bottom by, I have to multiply the top by, or whatever I multiply the top by, I have to multiply the bottom by. How did I go from 1 to 2? I'm either going to multiply or divide. It's never adding or subtracting on these. Well, I'd multiply it by 2. If I multiplied at the bottom by 2, I have to multiply at the top by 2. So if I had 2 tables, then I would have 10 students, because 5 times 2 is 10. They give me the next top number, then I have to ask, well, if I started with 5, what did I multiply or divide it by to get 15? Well, then I multiplied it by 3. And therefore, I have to multiply the bottom by 3. And 1 times 3 tells me I have to have 3 tables. In the same way, I'd multiply 1 by 4 to get the 4. So I have to multiply at the top by 4. And therefore, I know I could have 20 students. On this one, it says that I have 7 pencils for every 1 student. So I know I'm increasing by 7s at the bottom, and I'm just increasing by 1 at the top. So if I had 1, then I multiplied it by 2, and by 2, and 7 times 2 is 14. If I go from 1 to 3, then I'm multiplying by 3, and by 3, and 7 times 3 is 21. This down here is 28, so I know I'm multiplied by 4, and I'm multiplied by 4 at the top, which tells me that I would have 4. Should be, once again, a very basic thing to remember. Now this one, it becomes a little bit more complicated. I'm going to tell you that you can use this pattern. I don't find it as easy as another way to do it. But what they're saying is if I know what 2 numbers I'm talking about comparing, I find them in a row, and then I go down their columns, and I match up my numbers. So here's the example that we can do together. It takes me through it, but it says find the 6 and the 16 in the same row. And when you go through, you would find 6 and 16 in the row for 2s. So then it says choose a pair of numbers from a different row in the same columns as the 6 and the 16. So I have the column of 6 and I have the column of 16, and then I have to choose two numbers that are even levels to match up. So I just randomly picked the 24 and the 64. They're straight across from each other. They're in the same columns. They're in the same row. So 24 and 64 tells me that a ratio of 6 to 16 is equivalent as 24 to 64. Now, I don't find that nearly as easy as, instead of doing a chart, just asking myself, if I go from this to this, what would I have? So one of the things that I've told you before when we did this lesson was just multiply by your next two numbers. If these are being multiplied by 1 to start out with, then just multiply by 2, multiply by 3. You can multiply by anything as long as you get correct ratios. I'll check them, calculate, and make sure they're correct. You'll get the credit. I truly find multiplying by 2s and 3s is the easiest way to do it, though. If I do times 2s, and I know that I have a ratio of 5 to 9, then I just have 5 times 2, and I have 9 times 2. That gives me 10 over 18. If I then just multiply by 3, which is my next counting number, then I would take 5 times 3, which is 15, and 9 times 3, which is 27. So two equivalent ratios would be 10 and 18, and 15 to 27. Once again, as long as you do them correctly, you can do 100 times 100, and I'm fine with it, as long as your math is correct and you get proper ratios. Same thing with question 3. Instead, I'm going to use H6. Notice it's an improper fraction, and this is where we have said before in a couple of the previous review lessons. The only time I can have improper fractions is when I'm doing ratios and rates. This is fine, and it has to stay that way. The only difference is I could reduce it. I'm still going to do the same process, though, and I'm going to multiply by 2 and multiply by 3. If I multiply by 2, 8 times 2 is 16, and 6 times 2 is 12. So I have 16 to 12. Then I do by 3, and I have 8 times 3, and I have 6 times 3, and I get 24 over 18. Now, if I wanted to make it smaller, if I wanted to reduce it, I could. I could divide by 2 and divide by 2 and get 4 to 3. It's still an equivalent ratio. As long as I have two correct equivalent ratios, I get the credit for both points. All right. So then if I'm just given a ratio chart without any extra information, then all I have to do is that same process. Multiply it by something to get the same equivalent ratio in top and bottom. And once again, I would just multiply by 2s and multiply by 3s because it really is the first two easiest ones. So 7 times 2 and 2 times 2 would give you 14 to 4. Then when I multiply 3s, I get 3 times 7, which is 21, and 2 times 3, which is 6. So my ratios would be able to match up, and I'd be able to say that they are indeed equivalent one to another. So you go ahead and do 2, and then check your answers. So you could have done any equivalent ratios that you wanted to. I, once again, did 2 and 3. So you could have different answers, but as long as they check out mathematically, you're good to go. So when I do my 2s, I have 2 times 2, which is 4, and 5 times 2, which is 10. And then when I did my 3s, I'd add 2 times 3 and 5 times 3, which gives me 6 to 15. Should be pretty easy, right? All right, so moving on. Determine whether the ratios are equivalent. Now there are two different ways in which I can do these, and I'm going to show you both ways. And yes, I know there's a couple of you that are going to complain that it's just extra talking, but the extra talking is to teach you something. Number one, that there's always more than one way to do math, and number two, I show you both ways that you can use and will be using next year's 7th graders. So when I look at it, I could just begin by asking, is one of these going to go into the other one equally? And I see the 5 goes into 10 equally. So if that's true, then I would ask, what am I multiplying the 5 by to get the 10? Well, I'd be multiplying by 2. And that means I have to multiply my numerator by 2. And 4 times 2 gives me 8. Then I just simply ask, are they the same? They're not. I have 8 to 2, or 8 to 10, excuse me, compared to 7 to 10. They're not equivalent ratios. So how about these over here? Do I have anything, either of these that will go into the same number? I don't. So what we did with fractions when we compared fractions is we came up with common denominators. I would do the same thing. So I'd get a common denominator by multiplying by the opposite denominator. And over here's a 4, so I'm going to multiply top and bottom by 4. In the same way, here's a 9, so I'm going to multiply top and bottom by 9s. See what that gives me. That gives me 4 times 4 is 16, and 9 times 4 is 36. And then when I'm over here, I get 9 times 7 is 63, and 4 times 9 is 36. I have common denominators. Are my numerators the same? They are not. So they are not equivalent ratios. But the other way that I could do it is by multiplying the loops. Cross multiplication is what a lot of our older books used to call it for this section of math. And then comparing the answers. If the products are the same, then I know they are equivalent fractions. If the products aren't the same, then they're not equivalent. We had no and no before, so let's check this process. So when I talk about the loops, once again, I'm talking about multiplying diagonally. So 5 times 7 gives me 35. 10 times 4 gives me 40. Are they the same? They're not. So they are not equivalent fractions. When I do the same thing, I would take 9 and 7, which gives me 63, and 4 times 4, which gives me 16, and once again, they're not the same. Either way works. I don't care as long as you show me your work. Well, how am I showing work? I'm showing that I'm looping these together. And when I loop them together, notice what symbol I end up with. Multiplication. So I know I'm cross multiplying. And then I put my products. It's easy to show your work. Use equivalent ratios to find the unknown value then. All right, so 2 ways I can do these. I'm going to show you both ways. If I look at the pairing that is there, I have a 49 and a 7. This is not a pairing because I have a letter there. That's algebra. Okay. What would I do to 7 to get 49? Well, I'd either have to multiply or I have to divide one or the other. I could say I'm dividing 49 by 7 to get 7, but I can't divide k by 7. So I'm just going to go backwards from over here. 7 times what is 49? Well, 7 times 7 is 49. And if I multiply my numerator by 7, I have to multiply my denominator by 7. So I know 7 times 11 is what? Well, that's 77. So k has to be equal to 77. I do the same thing on 14. I have an improper fraction, but that's fine because it's not a fraction in this case. It is a ratio written in fraction form. So I'm going to leave it as an improper, but I'm going to ask, what am I doing to 5 to get 25? Because I can't do anything to 6 to get a letter in. Well, I would multiply it by 5, and therefore I have to multiply my numerator by 5. And 5 times 6 gives me a numerator of 30. So I know my n is 30. Now, when we did these before, the other way that I showed you was called dividing the loop. So if I divide the loop, it means I have to loop the sets that is there, and then I divide by the lonely number. So the loop, once again, is the 49 and 11. It's the only 2 pairings that are there because I can't do anything with a k and a 7. When I multiply those together, I get 539. The lonely number, the one that's left, is what I'm going to divide by. So it's going to be my divisor on the outside of the box. When I divide 7 into 539, handy dandy calculator, 539 divided by 7 tells me it's equal to 77, which is what we got before. When I look at this one, then my loop that's there is the other diagonal. I'm going to take 25 times 6. Well, if I have 6 quarters, I know I have 150 cents or $1.50. So I would have to take my 150 divided by the lonely one, the one that's left, which is the 5. It becomes my divisor, and 5 goes into 150 30 times, which is what we had before. So either way that you choose to do it is fine, as long as you're showing your work. If you show your work, you get the credit for the answer and showing your work. Pretty easy lesson. Should be easy for everyone. It's less than 15-minute video. So take the time to watch the video and remember the things that I'm trying to teach you. Get an A on the assignment. Helps your grade.